Okay, so the takeaway that I wanted you to have today is basically to understand the different steps in fine tuning a model, right? So here I'm taking an example of Llama 2 and data set from Hugging Face to fine tune. But what I want you to take away, I think probably this slide is something that I definitely want you to take away is, so if you have to fine tune a model, right? If you're thinking about fine tuning a model in an organization or for personal work or whatever, so I will tell you what are the different steps that are needed to fine tune a model. So that's a key takeaway. So typically you start with a foundation model. Yeah. So this is something that you identify because there are multiple foundation models in the market. Not all are open source. So it's a combination of open and closed source models that you have. So Llama 2 is one of the high performing open source models. I think last week we also had the announcement from Databricks on DBRX, which is another open source foundation model. So the first step is to identify what is your foundation model, right? So what is that you're going to do? So what is it you're going to take? So typically, from my experience, so what organizations or teams do is, so they try to go with take a faster approach, right? So based on, if you remember the two slides before, prompt engineering is definitely faster. So once you have your model identified, so you will start with using prompt engineering for your use cases and see how it fares, how the model fares, right? So typically it is more about cost versus benefit. If you really need a simple use case or try out your foundation model, you typically start with prompt engineering and identify what the prompt engineering cannot do for you, so that you have to do a fine tuning. So the once you choose that foundation model, the next step is to see whether you really need fine tuning. Okay, so once you're convinced that you really need fine tuning, the second one is choosing a data set. Yeah, so in this particular example, I'm using open source data set from Hugging Face to fine tune a model. So the data set is nothing but it has prompts. Okay, so it has, for example, Q&A. It has the prompts, and then Hugging Face, as you might be aware, Hugging Face is more of a model hub, right? It's a model register. It's a place where you go to get your data sets, models, fine-tuned models. For example, you go and get to use it. And then they do have data sets specific to the foundation model. So for example, the one that I'm going to choose for this session is a fine-tuned is a data set that is whose prompts are designed to work with Llama 2, for example. So if you want to fine-tune, let's say, a different model, let's say you take a cloud model or a Cohere model, whichever you want to fine-tune. So you need to choose a data set with prompts or with data that is customized or optimized for that particular foundation model, because otherwise your foundation model is not going to make sense of the data and your whole fine-tuning is not going to work in favor of you. Okay, so this is the second step. The first one is choose the foundation model. Second, once you're convinced that fine-tuning is needed, choose the sample data set that you're going to fine-tune your model with. And the third one is to choose the methodology. So in the previous slide, we saw 4 different methodology for PFT. So if you're going to do a full-fledged fine-tuning, so you will that takes a different approach. So here we are making an assumption that we are going to use the PFT method, right? So third one is to choose which method is good for you. Okay, so again, you weigh across your use cases, the needs that you want to do, and also your appetite for the money you want to spend, and then what is the output that you're looking for. And then you come up with what is the algorithm or what is the method which you are going under PFT you are going to use the fine-tuned model. So in this particular example, I'm using QLoRa, which is a variant of the LoRa that you see in the last screen. And typically, normally, I think it is 16-bit precision, which needs a typical GPU to run your fine-tuning. But we can reduce it to a 4-bit precision, which is going to give you a little bit lesser performance, but optimized for the cost of fine-tuning. So the third step is to choose the algorithm, choose the precision that you want your fine-tuning to have. And fourth step is to define your training parameter. So this is a parameter. So PFT has a set of parameters so that you will have to send as input. So I'm taking some parameters I have used from an online example. So I will also give you the reference to the notebook that I used as a reference. So you define the training parameter. So that is going to be applied to the model. And the last step is to fine tune the model and evaluate the response. Okay. So typically, any fine-tuning that you want to do follows these 5 broad categories. the content of it, and some of the steps could be broken down into multiple steps depending on your need. But this is the workflow, or these are the steps that you normally follow to fine tune the model. Okay, so I'll go through the code. Later I will switch to the notebook to see how much we can go through on that. So typically you start, so this one is written on, this is on Python, and then we will be heavily using Hugging Face libraries to load the data set, to fine tune the model. So here on this first part of the notebook, what you see is the installation of the required library. So you have Accelerate, for example. So this is a PyTorch related library, which is enabling your code to run on multiple configurations. So the second important one is the bits and bytes. So this is your Python wrapper around the CUDA custom function. So this is typically used to run your the fine-tuning code on your GPU hardware. Anyway, in this particular example, so we'll be running it, we'll be able to run it on CPUs, but this is a library which abstracts where you are running your fine-tuning. So that's a bits and bytes. You have transformers. So this is the transformation. This gives access to the transformation layers of your model, and this is again a library maintained by Hugging Face. And PFT is mainly the model, so the one that you see here, right? So this is what we will use to run the fine-tuning on the model itself. So this is the core of the fine-tuning. So I think most of these are provided by Hugging Face as an open source component. So first we'll start with installing the required libraries, and then you import the data sets. This is one of the good practices from Python world. So where you import specific modules within your library, whatever you need. For example, from the data sets, we are importing load data set. So this is what we will use to load the test data set that we will use to fine tune our model. And then from the transformers, so we are loading the different modules that are inside the transformers library. From the PEFT, we are loading the LoRa config, because LoRa is what we will use to fine tune the model. And then lastly, we will import the SFT Trainer module from TRL library. So this is what we will use to run the training itself. Yeah. So you start with installing necessary libraries, import the specific modules. So once you do that, the second step is for you to define the foundation model, the data set, right? So three things. So if you remember the different steps, I told you choose the foundation model, you choose the data set. That's what we are doing in this particular slide. So on the left hand side, you see we are starting with a Llama 2 7 billion parameters model, which is optimized for chat. And then this is provided by Hugging Face. Okay, that is what the name means. And then for this example, we are taking it from news research space, because typically when you want to use a model like this from Hugging Face, you typically go through an approval phase. So you say that, okay, I want to use the model for so and so purpose, and then they approve it for your email before you can use. But if you use from this news research, you are able to get access to the model right away. Yeah, so you don't need to wait for the approval process. But otherwise, it's the same Llama 2 7 billion model that is provided by Meta and then hosted by Hugging Face. Okay. So the next one is the instruction data set. So we will again load a data set which is optimized for Llama 2, and then this is nothing but a set of question and answer pairs. Okay, so it will have different knowledge questions, for example, about some historical figures, about some countries, about some. So it's basically some sample training data set that you will train your data on. So this is a 1K data set, so it's 1,000 samples that is optimized for the Llama 2 prompts, as I explained earlier. And the last one is more like a holder. So this is our fine-tuned model. So once we run the fine-tuning, we will store this into a target model, and this is the model that you can use for running your internal LLM apps. Yeah, so you can host it, run it on ML LLM apps, or even distribute it depending on the license agreement that you have with the foundation model. So for example, some models don't let you modify and distribute, so you need to be mindful of any restrictions that come with the foundation model before you can distribute the models. So this step is where you are defining for base model, defining the data set, and having a variable to hold your fine-tuned model. So the next step is the quantization step, right? So the quantization is nothing but basically you are reducing the precision. Yeah, so typically you have 16-bit precision, which is going to give a good performance, but at the cost of the time it takes to fine tune and also the resources that is needed. So we are quantizing it, nothing but, so we are reducing the precision to 4-bit here, and that is what this does. So bits bytes config is the library that we use to quantize the model that we take. And what we are doing now is just defining a configuration, right? So later when we fine tune the model, we will pass this configuration to it to tell our fine tuner, the SFT, which is going to fine tune, that we are going to quantize it to a 4-bit configuration before fine tuning the model. Yeah. So typically 4-bit allows you to run it on consumer hardware, so which means you can even run it on your local workstations. For example, I haven't tried it. I just tried it on the Collab notebook, but I can share the notebook code with you. You can also try it on your local workstation if you want to take a look. But the 4-bit quantization typically makes it possible if you have a good hardware on your workstation. And then we are using the NF4 type configuration using bits and bytes to do this. Okay, so the next step is you load the dataset, right? You load the dataset, and you also assign you configure it to create a model on the base model, and then you also set up a tokenizer. So we'll go step by step. So the first one, where you use the load dataset, this is the dataset. If you remember in the previous slide. So we are defining the dataset to come from, it's a Llama 2 Guanaco dataset from the Hugging Face, sorry. So you are loading that particular dataset, and then here the split train means that the training portion of the dataset will be loaded. So the datasets typically in this particular dataset, you have only 1,000 samples. So there could be dataset which could contain both the training dataset and an actual dataset. Yeah. So typically when if you look at the ML world, you always split your dataset into a training dataset and an evaluation dataset, right? So typically you split that. So by mentioning split equals train, what you tell this method, the module, is you load the dataset and only the training part. Yeah. So since this dataset has all the training sample, it doesn't make a difference. But typically a good practice is to say, if you're using a dataset to train something, you split it by, you mention the split parameter to load only the training part of it, right? And then second one is where you are taking the base model and you are specifying the quantization. So base model, if you remember 2 slides back, we set it to a base model variable. And then we are using this method, auto model for causal LLM from pre-trained is nothing but this helps you define your base model to your trainer, which will come later. And then you are specifying the quantization config, which is a 4-bit quantization. Yeah. So and then the device map is mainly used to, so whenever you are running this fine tuning, the device map says use the first available hardware. Yeah. So the value that here you say 0 means it can run on first available hardware. The reason to specify this parameter is sometimes you want to run it on a specific GPU, for example. Okay, there might be a need to run it on a specific GPU. So here in that case, you can specify a device map to say it has to run on a particular hardware. But since we don't have any specification on where to run, so we just mention 0. Yeah. So and then you have set a few more parameters. So the use cache false, it disables caching in your model configuration. And then this TP is nothing but your temperature. So temperature is mainly to reduce hallucination. So higher the temperature, lower is the hallucination. So here we are setting it to 1 for default. So this one says that you set the temperature to 1. Okay, on your trained model. So these are all the different key parameters, and the bottom is where you set your tokenizer. In simple terms, a tokenizer is nothing but converting your the English and the natural language stuff into machine understandable format, which is nothing but bits and bytes, right? So it's we typically call it as vectors. So tokenization here is nothing but it's taking this data set that you are passing to it, and then it is going to tokenize it. So we are setting up a tokenizer to the base model, and then later when you train it, the tokenizer is going to tokenize so that the model, the underlying machine can understand what we are training it against. So these are 3 key things we do. We load the data set, we set up the model, assign it to the base model with a few configuration parameters. You also define a tokenizer and tie it to the base model that we are going to run fine tuning on. Okay, so the next, this slide is where you are setting up your parameters, right? So the first one is the PFT parameters, second one is the training parameters. So the difference between the two is, so the first one is where earlier we talked about the different ways you can apply PFT, right? So we are going to use LoRa here. which is a causal language model. So causal is nothing but, so you have cause and effect. So you ask something, something happens, and the model responds with something else, right? So for example, Q&A is causal. So first we define the parameters for the causal for the LoRa configuration. So basically you start with the LoRa alpha is 16. So basically this sets there are hyperparameters in the configuration. So basically you set it to 16 in this particular main. So it depends on the specific implementation of LoRa. So it controls the rank of the factorization used for compression. So these are some of the technicalities in LoRa. So you say that this is the factorization that you want to use to when you are running the LoRa fine tuning on this particular model. So the 0.1 is again a regularization technique that is used. So we set a dropout rate of 0.1. So lower the rate, so it prevents the overfitting. Yeah, so overfitting is where the model tries too much to fit the data set into the model's space. So it prevents overfitting. So higher it tries to do overfit a lot. So the lower value prevents overfitting. So the 0.1 that you see here, it prevents overfitting. And then there are a few other hyperparameters and so on. There is this bias is none, so which tries to reduce the bias in certain parts of the network. And lastly, the causal LM is where we are saying we want to use LoRa-based causal language model, and that is what the last parameter is all about. And then the next one is on the training argument. So these are all the fine-tuning parameters. The first one is we tell what configuration for the fine-tuning algorithm that we want to use. Second is what are the training parameters, which means so where do I want my results to come in, what are the logging step, learning rate. Even honestly, I'm not aware of all these parameters, so I took a reference values from one of the notebooks I got on the internet. But just remember for this conversation that this is where you can customize the various parameters that go into the training itself of your model. Okay, so these are the two parameters, the PFT params and training params. You'll see in the latest slide, we will use this when you're running the training on our model. And then the last one is where you define your trainer. Yeah, so the trainer, the SFT trainer, is called the supervised fine tuning. So what we are doing is supervised because we are taking a data set and then we are asking the model to learn our data set. That's what ultimately we are doing. So we are using the SFT library, is coming from Hugging Face. SFT Trainer is the module that we will use to train the model, right? So here is where you connect all the different pieces that you are putting together. So the first one is, so you are setting the model, which is the model that you are going to train. So if you go back to few slides before, so this is where we set up we attach the foundation model and set the model parameters. So you start with the model, you define the data set on which you are going to train, you set up the PFT configuration for your algorithm. You said the dataset text field, so this tells you about the type of the field. So it's all text. We are not using any multimodal stuff here, no images and so on. Then you set the tokenizer, then you set the arcs, and then we are good to go. So basically this is what is going to do the magic for you. And then once you do that, you run the train method. So in your notebook, so this is the method, or this is the call, which is going to take normally most of the time. And if you're using, let's say, a free collab notebook, this is where it's going to fail most of the time, because it will try to allocate a specific RAM to run this for you. And if you're on a shared infrastructure or hardware, and you're not able to allocate the RAM to run this training, and this is a step where it is going to fail typically. But otherwise, if everything goes well, and this is a step where you will train the model, and then you will get your output as a trained model. So then you will save the trained model into the new model. If you remember, new model is where we have defined to store the output of the fine tuning exercise. So this is where we'll save the new model. So I hope this gives you an idea of what are the different steps that it takes to take a model, take a data set, libraries that you want to use, and how do you train the fine-tune a model using PFT LoRa. Okay, so the next two, just a quick, so during one of the successful runs, so this is basically the first one is on the, once you complete the training and store the new model, you can go into the results and then see the runs. So this is going to have some interesting information to tell you what happened during the training process, right? So there is, for example, what is the learning rate, As you can see in this particular case, the learning rate is stable. So you don't see any fluctuation in the learning rate. And then the loss is basically it is going to tell you about any data loss, anything that was lost, which means that you're trying to train on some data points, so there might be some losses, so due to various reasons. So we don't see a huge variation here, but any huge variation will tell you that okay, so even though the training is successful, the output is not going to be as good as what you're expecting, because there is a huge data loss that has happened during the training process itself, right? So this is some interesting information, and all this will be stored into the runs directory under your results, and then you can run some charts or TensorBoard charts on this to see what is the outcome or output of running your training. Yeah. And then the next one is where you're testing the outputs. So this is basically your testing. So typically, so we are testing, it's more like a unit testing, right? So you're testing the code here. So this is how you normally test. So here, for example, you can define a prompt here. So for example, in this case, we are asking who is Leonardo da Vinci. And then you set up this variable. So the model that you have, the tokenizer that you have, and the text. So this is a text generation model. And then you take the result and pipe the result to display it to you in a user-friendly format. So basically, you can repeat this multiple number of times using the different prompts that you want to try with, and then you can see the output from the fine-tuned model. So for example, for this particular prompt, so this is going to give you a response like this. So your INST, so you're earlier asking like Altaf, so here you see, so this particular tag that you see here, INST/INST, is going to separate out the question or the prompt from the response that we are going to get, right? So this is specific to Llama in this case. So this is the question that we asked, and this is the output that your fine-tuned model is going to give for you. So typically, ideally, there should be, if your data set contains some data points about your organization. So for example, let's take HSBC for example, right? So typically an open source foundation model may not have a lot of information about, let's say, teams in HSBC. It might know HSBC from a public company point of view. But if your data set has something that is very specific to your team, for example, the team led by Altaf, so the number of team members there, who do they, what does a team do, for example, if your data set has some questions. So typically you can use this to test, right? So you can probably run this test before running fine tuning and see the response that is coming from models. So typically it will be something that is unrelated or stupid, for example. And then after you train, you can compare the output that is coming specific to the data that you fed it in. And then that's where you will see the effect of fine tuning that you have run on the model. Okay. So that is what I had in terms of slides, and then I will share these links with you later. So the first one is for the notebook. You can use this link to make a copy of the notebook and run it in your own collab environment. The second one is a good article from Hugging Face. I took some notes from there for my slides from PFT. And finally, there is a good article on fine-tuning Llama 2, so you can refer to it for step-by-step instructions also.